Creating project application 21. Yesterday we have learned some methods of object class. Today we can learn some more methods and we can complete learning object class. Creating new class, manager. I need main method, created. In manager class I am taking variable str string. How to initialize the variable? You can create object to constructor to the manager. We can initialize the str. Start str equal to str, but here we have to provide argument. Creating an argumented constructor to create the object to the manager. Control space to show the constructors. This is straightforward. We created a manager class. Inside manager class, I have a string str, and I have public manager constructor, which is taking the argument as a string, and whatever argument we are getting the value. That value I am taking in the constructor, and whatever value is there, we are just assigning to the current class, manager class attribute. Now, in the main method, I am creating two objects. Manager m1 equal to new manager. Object is created in the memory. And whenever we create the object, constructor is executing. The ABC value is assigning to the manager class attribute, because manager class is having attribute str string type. So similarly, manager2. Now this object is created. Manager2 object is created in memory. In manager2 object, constructor is executing first. Inside the constructor, the value ABC is assigning to the attribute of manager2. Here, we have to learn one concept of garbage collection. If you have an application, inside your application, we have 1,000 classes. All 1,000 classes, we are creating objects, we are using the objects. After using the objects, we have to delete the objects in the memory. Otherwise, if you are not deleting the objects in the memory size will increase, and we will get the error of the out of memory error. We can learn more about the out of memory error when we go to the exception handling. What is the error? What is the exception? We can learn more in the next topics. Now here, if objects are created in the memory, who is deleting that objects? If after you use the object in manager class, I am using my objects M1 and M2. After I am using the objects, we are not deleting the objects. Who is deleting that objects? By default, automatically Java is supporting garbage collection. This is one feature of Java programming language. Once we create the objects, once we use the objects, if object is abandoned, here we have to learn some terms. What is object is abandoned? Now whatever objects we have here, manager M1 and manager M2, these two objects are the live objects. Object is created in the memory. Whenever we call new operator of manager, object is created in the memory. That object is having a link of reference is M1. M1 is the object identifier. M1 is pointing to that object. That is called linking to the manager object with the M1 reference. Now, what is abandoned object? The object which is not having any reference. It's called abandoned object. Now here, whatever object is having a reference, those objects will call live objects. We can use that live objects. If object is abandoned, we cannot use that object. Using the object means reading the data of the object. Now, this is a live object. New manager ABC, which is having reference of M1. If you want to use the object means reading the attributes of the object. I can call a system.println of M1.str. So I'll get the ABC. That is called using the M1 object. Now, how to make the object abandoned? We call M1 equal to null. Whenever we call object reference equal to null, so we are just removing the link between the M1 to object. Now, what is the object? Whenever we call new operator, I'm just recapping again. New manager object is created in the memory. If you're not giving manager M1, so there is no link between the object and the reference. If you give manager M1 equal to new manager, so M1 is referring to the object, which we have one link between the M1 reference and the object. When we can unlink that object, we can, if you call M1 equal to null, so we are just removing the object reference. Now, whatever object is a new manager, this is called abandoned object in the memory. If you unlink the object, how to make the abandoned object? If you call object reference equal to null, that is the way to make the object as a abandoned. Now M1 object is abandoned, M2 object is not abandoned. If you call system.println of M1.str, we'll get exception. Now we won't get compile time exception because M1 object is already there. We initialize that object, we are making that object as a null. Now we'll get here one exception. M1.str means we'll get null pointer exception. Because whenever object is abandoned, it will become as a null. So if you try to access the members of the null, we'll get the exception, null pointer exception. We'll learn more about the exceptions later. For now, M2 object is live object. We can use the reference of the object. M2.str. This is having the reference. M2 is pointing to this object, so we'll get the ABC. This is called live object. This is called abandoned object. Now, by default, Java programming language supporting the garbage collection. See, whatever abandoned objects are there inside the memory, JVM will take care of calling the garbage collection method to delete the all abandoned objects. That is happening not in case of some particular time, not it's related to daily, not it's related to time, something like a minute wise or hour wise or monthly wise. Once in a while, garbage collector will come. It will execute that garbage collector method. So whatever abandoned objects are there in that time, it will go and delete that objects. It will be 1 minute or it will be 2 minutes, 3 minutes. Once in a while, garbage collector JVM will execute the method system.gc to delete the all abandoned objects. How to delete the abandoned objects? This garbage collection is very important. Now, how to delete the garbage collection? Our own. How to write a code to delete the garbage collection, like abandoned objects in the memory. I'll take new class. String s1 equal to new string of ABC. Inside manager, I'll take string object. String str. I'm not using any constructor, but here manager1 m1 equal to new manager1. I'll create the default constructor. Object is creating using the default constructor. Then m1 dot str equal to s1. We can assign the values to the object attributes using the directly attribute also. M1 dot str equal to s1. How to initialize the attributes? By using the constructor, we can initialize the attributes. By using setter method, we can initialize the attribute. Directly also, we can initialize the attribute. This is also third way of initializing the attribute. M1.str equal to s1. Now I have created M1 object. This is a live object. We can use this object. Let's create one more object. M2 equal to m2.str equal to xyz. Now here, I want to make this object abandoned. I want to call the garbage collection my own. We don't know when our garbage collector will call, when it will go and delete the all abandoned objects. In my project, we created so many classes, like hundreds of classes. We make so many abandoned objects, but we got the out of memory error. That time you have to call manually the garbage collector. How to call the garbage collector? We have system.gc. Inside system class is already developed by JDK developers. It is from the java.lang package. From system class we have GC. GC is for the calling the garbage collector. It runs the garbage collector. Now, whenever we call the system.gc, we don't have any abandoned objects in this class. Before calling the system.gc, we have to make the object as abandoned. Now we not make this abandoned. So I'll save this, I'll call this. Now nothing will happen because we don't printing any message also. Now, how to know garbage collector is running on this object or not? To verify the garbage collector is running on this object or not, whenever this we call garbage collector system.gc, before going to the memory and deleting the abandoned objects, it will go and execute the object class finalize method. We have finalize method in object class. This is another method of object class. I'm just putting a message system out of finalize method executed. By default, it is calling the object class finalize method only. Before, whenever we call system.gc, before going to the garbage collector and deleting the abandoned objects, it will execute the finalize method. Now, if you go and see here, we don't have any abandoned objects. So, before going and deleting the abandoned objects, which is going executing the finalize method every time. If you have 2 abandoned objects, it will execute the finalize method 2 times. If you have 10 abandoned objects, it will go and execute the finalize method for every object before going and deleting that. Now, how to make the abandoned objects? I want to make M1 object abandoned, M1 equal to null. Now we have 1 abandoned object. Now we will get the output of finalize method executed only once, because inside the memory we have 1 abandoned object. Object is not having any reference means abandoned. So if you call this, we will get the output of finalize method executed only once. Now I'll make the M2 object also abandoned. Whenever we make 2 objects is abandoned, 2 objects are created and 2 are making as abandoned. No reference to the abandoned objects. Now, whenever we call system.gc, before going to the garbage collector and deleting those 2 objects, abandoned objects, it will execute the finalize method 2 times. For every abandoned objects, first it will execute the finalize method, then it will delete the object from the memory. How we can know the garbage collector is deleting the abandoned objects? We can see we can override the finalize method, we can identify. If you now, I'll create one more object. Now this is just a reference. Manager1 M3 equal to null. We just declare the variable. No object is not created. If you tell M3 equal to null, this is abandoned. No, it is not abandoned because M3 object is not created. Simply we just declared one variable with the reference type is manager1 type. Now if we call this, it will call only 2 times finalize method. If you see here, sometime we will get the only one finalize. Sometimes we are not getting any finalize also. See, even though if you call system.gc, this is very important point. Even though if you call system.gc garbage collector, it is not mandatory to call finalize method for each object. Now, the question is, can we tell garbage collector to go and delete the abandoned objects strictly? The question is, can we tell the garbage collector go and delete all abandoned objects forcibly? If we call garbage collector by calling system.gc, it is not an order to the garbage collector to go and delete the abandoned objects. It is just a request to the garbage collector. We have the abandoned objects. If any abandoned objects are there, if whatever you have some scheduled time, free time, just go and delete that abandoned objects. We are just notifying the garbage collector, go and delete that abandoned objects. Now I just notify this, I am calling this method, I am calling executing this class. We are not getting any finalize method because we are just notifying the garbage collector. So once in a while it will go and delete it. Whenever it is going and deleting that object, it will execute the finalize method first, then it will delete the object. Now it is not deleted the abandoned objects here. In this, whenever we run last time. Now again I will go on to. Now it is going and deleting the two objects because it's going the finalize method. Even though if it is whenever we execute our code, if it is not deleting also, in background it will go and delete, but we won't get the output of finalize method that time. It is the important thing is here, we are not forcibly telling to the garbage collector to go and delete the abandoned objects. We are just requesting the garbage collector, whenever you have free time, just go and delete that abandoned objects. The system.gc is just a request, not an order to the garbage collector. Now, what is the finalize method? Finalize method is from the object class. If you want to know, before deleting the abandoned objects, garbage collector will call the finalize method. If you go and see the description of this finalize method, it called by the garbage collector on an object when garbage collection determines that there are no more references to the object. If there is no reference to that object, that is called abandoned object. If it is finding there, it will call, garbage collector will call the finalize method.
Nothing but label.
Yeah. This finalize method, the most important point of the finalize method is see, once we create the objects, we use the objects. If you want to clean the objects, garbage collector also will call the finalize method on this class, manager1 class, to clean the manager1 objects. If you want the main use of the finalize method is once we create the objects, we use the objects. We can make that object as abandoned. Object equal to null. After making that object is abandoned, then if we call the finalize method on this class, so we are telling the manager class to go and delete the abandoned objects. Finalize method also will do cleanup activity. To delete the objects in the memory, garbage collector also will call the finalize method of that class. This is the importance of finalize method. Now here in one real-time example, see we have everything is in Java is related to data, like adding the data or updating the data, deleting the data, or getting the data. So data is a called class. Class is having attributes. Data is having the we can say data is a one table in the database. Table is having the columns. Each and every column is a one attribute of the class. If you take person class, in database we have person table. Person class is having name and age. In person table also we have name column and we have age column. In name column we have all the names. In age column we have all the ages. Similarly in person class Whenever we create object to the person class, we can give the name, we can give the age. Now it is both are both are having some interaction. The object and database record of the table. Now here, to connect to the database from the Java code, we can learn more about the JDBC later. We have one JDBC framework. This is called Java Database Connectivity. We have one connectivity, JDBC. Using JDBC, first we have to create the objects to connect to the database. After connection of the database, we don't want to use that object. We have to delete that object. How to delete that object? We can make that object equal to null. We are making that object as a abandoned. Then at the end, we can call the finalize method. We call the finalize method to delete the all abandoned objects. That is the use of one real-time use of finalize method. Now we have seen about the finalize method. Let's go to next method of object class. Class manager to main method. I have two attributes in the manager too. I'll create constructor of manager to create my object. Now we can create the object to the manager to class by calling the constructor. Now inside main method, manager 2 equal to m1 equal to new manager 2 of string is abc, integer value is 100. Now here I want to create the same object. I have manager 2 m1 equal to new manager 2. If you want to create the duplicate object to this m1, how to create? Manager 2 m2 equal to m1. System out dot println of m1. Now we not override the toString method, so we'll get the class name at the hexadecimal representation. Now how to get the data of the manager 2 class? We have to override the toString method. We need to bother about the data of the object, not the memory address where the object is stored. So I am just returning the toString method. S1 equal to S1. I am just printing S1 value, then comma I1 equal to I1. Inside toString, we are just printing the values. SY M2. Now we are just creating two objects and printing the two objects. We go and see S1 equal to ABC, I1 equal to 100. S2 similarly, whenever we manager 2 M2 equal to M1, we are just assigning the M1 like wherever object is created for the M1, same thing is referring using the M2. Now M1 and M2 both are pointing to this object. Object is same, references are 2. So we got the output as this 2. Now we created one object, we just duplicated that object. Now here original object is M1, Similarly, if you want to create the same object, we can give manager to m2 equal to m1. Now here, if I change m2 dot s1 equal to xyz, I'll print both m1 and m2. If you change value of m2 object, the value will change in the m1 also. Let's go and run this. See, now I change value to the m2 objects, but value is changed in the m1 also. s1 equal labels, i1 equal to 100. This is m1 object, this is m2 objects. Here I just change only the one value of m2. Because object is only once. Object is one. But references are m1 and m2, both are pointing to same object. Everything is in memory. Memory object is created. m1 is pointing to that, m2 also pointing to that. Now, this is one way of creating the duplicate object. How we have to create the duplicate object, actually we can see in the next program. By using object class method, how to duplicate the object. Manager 3 class main method. We have class person. For a person class, we have a name, int age. We have address also. This also I will create as a class. Insert address class. I will take attribute as string door number, string village, I have three attributes in the address class. Now I want to initialize the address class attributes. So how to initialize the address class attributes? By using constructor, we can initialize. See, the number is integer type, so I am taking as an integer door number. We can take any attribute. String village. Now everything is classes and objects, so I am creating class to create the address of the person. This dot door number equal to door number. This dot village equal to village. Now I have created the address constructor, 3-argument constructor. Now to get the data of the address, by default if we call system.println of address object, it will give class name @hexadecimal. So we need the data, we don't want the memory address. So I have to override the toString method. How to override it? Public string toString. Inside of toString, in address class I need first door number. Door number equal to door number, comma, village equal to space, then comma, pin code equal to space. We're just printing the data in the address class. Now I have requirement of only the printing the data. So I'm just printing the toString method in the address class. Now let's go and create a constructor for person class also. Inside person class, I have name attribute. All attributes I'm initializing using the constructor of the person class. Start name equal to name. I'm assigning current class attributes with the arguments of a constructor. So constructor is created for creating object. Now, if you call system order printer of person class, I need to print the data of the person class. How to print it? We have to override the toString method. Object class toString method will give the class name object hexadecimal. So I am overriding the toString method. Return name equal to name, comma, age equal to age, comma, address equal to, I'll put some power packet, address. Address is one type of object, so I am putting the power bracket to our differentiation. Now I am just printing the data of the person class. Inside person class, we have one more class. This class also overrides the toString method, so we'll get the data of this one: door number, village, and pin code. Now, how to create object to the person class now? Person P1 equal to new person. Name of the person is Ramu. Age is 23. Address is new address. Door number is 20. Village is NCL. Pin code is some number. Now I created one object. Print system order printer of P1. By default, the system order printer of P1, it will call P1.toString method. So whenever it is calling toString method is override or not, it will go and verify in the person class. This is P1. Inside person class, toString method is override. If it is not override, it will print the class name at hexadecimal. So inside the toString method, we are just printing first name equal to name. After that, age equal to age, which we are providing from the constructor. Then address. Address also we are providing 3 attributes to the address constructor. Now it will go and check here. By default, if you're not printing here toString method, it will take care of printing the address.toString. So we'll get the values of door number, village, and pin code. Let's go and see here. We go and see here. We got the output of name equal to name, age equal to age, address equal to the door number, village, and pin code. Now, how to duplicate this object? Using our object class methods, how to duplicate the object. This is the original object. We want to duplicate the original object. We have method of clone method. Which object you want to duplicate? Inside that class, we have to override the clone method. See here, we need to understand some important points when we override the clone method. See, whenever we override the clone method in any class, we must implement the clonable interface. Why we have to implement the clonable interface, we'll see. First, we can go and run this. We'll get some error. Based on that, we'll go and proceed with this. Person p2 equal to p1 dot clone. Whenever we call clone method on the original object, we'll get the duplicate object. See, this operation is cannot convert from object to person. Whenever we call clone method, this return type is object type. So it is not auto upcasting because object class is superclass. Converting from superclass to assigning to subclass value, it will give error, compile time error. So we have to typecast. We are telling to the compiler, this clone method will return the person class object. That is one first step we have to do in case of clone method. Now here, whenever we call clone method, the clone method is having the exception type of clone not supported. We have to throw clone not supported exception. This is the first step we have to understand when we call the clone method. Whenever we call clone method, we have to typecast to the particular class, which class we are converting. Then we have to throw our main method to the clone not supported exception. Because the clone method is throws clone not supported. We'll learn more about the exceptions when we go to the exceptions. But just now remember, clone method we have to call to create the duplicate object. Now if you run, we'll get one more error. Clone not supported error. See, to create the duplicate object to the original object, we have clone method. Converting one object to another object, like converting the duplicates, it is not a secure operation in Java. See, when we do the unsecure operations in Java, we'll get the compile time error. Like now we got the clone not supported exception. Cloning is an unsecure operation. So we need a marker to make this unsecure operation to the secure. How to make the mark? We have one marker interface, clonable. By using clonable interface, we can make our operation is a secure operation. Clonable is interface. This is a marker interface. Now the concept is, what is a marker interface? This is also important for interview. See, if you are doing any unsecure operation, if you want to make that operation as a secure, we have to tell to the compiler, this operation is secure by using the marker interface. In case of clone, in case of creating duplicate objects, clonable is a marker interface which we'll use for the telling to the compiler, this operation is secure, so I am proceeding with the creation of duplicates to my objects. If you not implement the clonable marker interface, we'll get the compile time error. We'll get the runtime error of clone not supported exception. Now, I'm making this clone operation as a secure by using the clonable interface. Now, if you call, now this operation is success. We created the duplicate object. After creating a duplicate object, I want to print that object. Now, whenever we print that object, see here we can see person object, person class. If you do the cloning to the person class, whatever person class attributes are there, those attributes will get copied into the person class object P2. But if your person class is having any other object, now here address object also in the person class object. Whatever address object attributes are there, those attributes not going to the P2 object. Let's go and run this. Now here, this cloning operation, as I said, it is not copying the address object attributes. It is copying the address class attributes also. So little bit correction is over here. Whenever we call the clone method of any class, person class, whatever attributes, even though it is a primitive or user defined, this is user defined class. If it is, this is a predefined class from the JDK. Whatever classes, whatever attributes are there inside person class, all attributes will get created as a duplicate object. Now we achieve this using the cloning method. Now in future, if you want to create any duplicate objects to your objects, we can use a clone method. How to use the clone method? What are the steps we have to use for the clone method? If you don't have Eclipse, if they are asking you to write your code, your own in the notepad, we are able to write it if you understand all the points. Now in my class, if my class having clone method, inside person class I have clone method. I have override a clone method from the object class. This clone is from the object class. Clone method return the object object type. Inside the clone method, I am calling super.clone. This is a super class clone method we are calling. Means super class is object class. Object class clone method we are calling. Now here, if you get a doubt, what is clonable? If you implement the clonable interface, why we not override any? Why we not implement any methods of a clonable interface? Let's go to the marker interface again. What are the points are there inside marker interface? The marker interface. What is marker interface? When to use the marker interface? Marker interface is not having any methods, any variables, anything in the body. Which is not having any body. Means interface clonable simply like this. For example, which is not having any unimplemented methods, not having any attributes. And then what is the use of the marker interface? The main use of the marker interface is if you are doing any unsecure operation. We need to make that operation secure. We can do it by using marker interface. If you are doing any unsecure operation, if you need to make that operation secure, we can do it by using marker interface. If you're not using the marker interface, we'll get compile time error. We won't get compile time error. We'll get the runtime error. Now, in case of this, our code, the cloning, clone method is used for creating copy of my object or creating duplicate object. Clone operation is an unsecure operation. Somebody asks, what is a clone method? What is the use of clone method? Clone method is used for creating the copy of the original object. Copy of original object or duplicate object. Clone operation is unsecure operation. So we need marker interface to make this clone operation is secure. So we need to make this secure. If you want to create any duplicate object to any class, first step, we have to implement clonable. We have to implement clonable interface, marker interface. Second one, override object class clone method. This is object class clone method. We just implement clonable interface. We just override the object class clone method. And then whenever we are calling object.clone method, we have to typecast that object to the particular whatever object you want to create, clone method, we have to create that. Wherever you are calling clone method, we have to throw clonable interrupt, clone not supported exception. Third one, whenever we call clone method that has throws clone not supported exception. These three steps you have to follow to make the duplicate objects, to create the duplicate objects. Now we have seen the marker interface, we have seen the clone method to create the duplicate. Now in cloning also we have two type of clonings. First one is shallow copy. Second one is deep copy cloning. First one is shallow copy cloning, second one is deep copy cloning. What is shallow copy, what is deep copy, we can see in the next program. We can go to next program. Go to next class. Manager 4. Now class tester. Int A, int B. Two attributes I have. Test of test constructor. A equal to 10, B equal to 20. Now class test2 implements clonable interface. I want to do create duplicates through the test2 object. Inside test2 into x into y test of t. I'll create test2 constructor. Inside test2 constructor x equal to 30, y equal to 40, t equal to new test. Now this is very simple. Inside class test2 implements clonable. I have two variables, int x, int y. Third variable is derived class, like our class. User defined class, test class is a t type. Inside the constructor test2, I am assigning x equal to 30, y equal to 40, t equal to new test. Now here, I want to achieve the duplicates, cloning. So I am just override the clone method. By overriding clone method, we can achieve the duplicates. So now inside main method, I want to create object to the test2. Test2 t1 equal to new test2. Now whenever we call system.println of t1, inside test2 object is toString method is not overridden, so we'll get the output as class name under hexadecimal. So I am overriding toString method. X equal to x, comma y equal to comma inside t. Instead of printing that going to the I don't want to the go to the toString method to override in the test class, so I will access from here only. How to access here? We have ABC, right? A equal to t dot a, b equal to now I am just printing the all attributes x, y, a and b. Now let's go and run this. Now we have output of x equal to 30, 40, 10 and b. Now we can call test2 t2 equal to t1 dot clone. To add casting to the test2, and then we have to implement throws the clone not supported exception. We will take care of this. Otherwise, we have to type over on this one. Close this one. Now I call system.println of t2. Now both values are same. Now we can go here. T2 dot now I want to change the value of the T2. Now T1 object is created. We created a cloning to the T1 dot clone and we assign to the T2. Duplicate object is created and assigning with the T2. Now I want to change the T2 object. T2 dot inside T2 we have a reference of T. T2 dot t dot b equal to 300. I want to change the value from 20 to 300. And t2 dot x because my value is 30, so I want to change to 300. Now t2 dot t dot b value is 20, so for our understanding I'll make it as 200. Now I want to change the values, I want to print the values. Control S. Now this is the values. Before changing I'll print the before both objects. I'm just making some correction. Now after creating objects, I'm printing the objects, two objects, T1 and T2. After changing the objects, I'll print both objects. Now let's see what is output. Now these two, before changing the values, just cloning the objects, we got the both are same. Now, after changing the values, we change the values from 20 to 200, 30 to 300. Now whatever attributes are there in the T2 class, X and Y and T. T is a test type. Whenever we change X and Y, the value is applicable only to the second object, T2 object. It's applying only the T2 objects, the 300. T2 dot T dot B, 200. It is changing in the both original object and duplicate object. This is the original object. This is a duplicate object. And whatever value we change here, this is changing to the duplicate and original both. Whatever value we change here, this is only for the original object. Now what is shallow copy and deep copy? See, whenever we do the cloning, if you change the original object, if changes of original object is reflecting in the duplicate object. Whenever you change the original object, if original object changes is reflecting in the duplicate object. That is called shallow copy. Whenever we do cloning, if original object is reflecting in the duplicate object. Now definition of the shallow copy. When object is created, if you create a duplicate object to the original object, if you change the original object, if changes are reflecting in the duplicate object, that is called shallow copy. Now here if you see, we just made the change to the original object 200. 200 is reflecting in the second object. But here x equal to 300. Whatever value we change for the x, t1 dot x equal to 300. The original object, the x attribute is not assigning to the t2 object. First point is, if you create a duplicate object from the original object, if we change the original object, if changes are reflecting into the duplicate object, that is called shallow copy. And the second point of the shallow copy is, see, if you have a class tester, we take example of if you have a class one. Inside class one, we have some variables. Inside class two, inside class test 2, we have class 1. Test is a one attribute. Now, if we change the attributes of the test 2 in the original, that changes are not reflecting to the duplicate object. Test 2 is not reflecting with the 300. Because if you go and see the execution of this, whenever we call test 2, t1 equal to new test 2. Test 2 object is created in the memory. Whenever test 2 object is created in the memory, first constructor will execute. Now x equal to 30, y equal to 40 in the test 2 object. T equal to new test. T equal to new test means it will go and execute the test constructor. Here values is a equal to 10, b equal to 20. Now test 2 objects are having the values of x equal to 30, y equal to 40, a equal to 10, b equal to 20. That is the first statement when it executes. Now t1 dot clone. Same object is created, duplicate object. That duplicate object is having the values are same values 30, 40, and 10 and 20. Now T2 is pointing to that object. Now system.println of T1, system.println of T2 will get the output as 30, 40, 10 and 20. 30, 40, 10 and 20. Now T1.T.B. If you go and see then the both objects are referring to the same T object. T equal to new test. It is referring to same test object. Test object is only one object, new test. So T object is same. Whenever we change the T object, the value is changing in the both objects. Like this to remove our confusion. Now T1.x 300. Whenever we change the original object, it is not reflecting in the duplicate object because new object is created, duplicate object. T equal to new test. Now, if you change the original object, if changes are reflecting in the new duplicate object, that is called shallow copy. That is the definition. Now, here we have one more point. Okay, let's go to the deep copy. Here in the same program, what is deep copy? Whenever we create a duplicate object from the original object, if the original object is changing, the same change is not reflecting in the duplicate object. It is called deep copy. Now here this is a same class. Inside the same class, how to make this class as a deep copy? See, whenever we change the original object, this is the original object, the change is not reflecting in the duplicate. Let's make it very simple. Only two definitions. We can create the duplicate object using clone method. Whenever we change the original object, if duplicate object is also changing, so that is called shallow copy. Whenever we change the original object, if original object changes are not reflecting into the duplicate object, is called deep copy. That's it. Now, this is an example of shallow copy. Whenever we change the original object 200, this is changing in the duplicate also. This is shallow copy. Why? Because this test method, T new test, same object is created, and same the T1 and T2 both are referring to the same T object. Because object is same, values are changing. Now how to make it deep copy? Inside the clone method, we have to create, whenever we call clone method and create the duplicate object, we have to create the T object as a new object. So here I am making as a T equal to new T. Now this is a different object. Now first case we have the same test object. So we are, whenever we change the original object, duplicate also changing. Now here, whenever we change the original object, duplicate is not changing because we are getting new test object here. This is the only change. Now if we run this, now T equal to new test. Whenever we call clone method, we cloned it and we created the duplicate object. T2 dot T1 dot test equal to T equal to B. Okay. This is also changing. How to make it deep copy? Now, if we go and see the execution. Now I have created a test2. First constructor of test2 will execute. Inside test2, we have two attributes xy and test_t. First constructor will execute inside the 30, 40 and t equal to new test. Now t having the constructor of a equal to 10 and b equal to 20. Now values are 10, 20, 30 and 40. First execution is completed. Now if we call t1.clone, t1 is test method, then it will call the clone method. Inside a clone method, this dot t equal to new test, and then again we are calling the super.clone. Instead of returning super.clone, this dot t equal to new test, then see, whenever we call clone method, manually I am calling the test2 object. So again it will call the constructor of test2, it will create the object to the test2. First x equal to 30, y equal to 40, t equal to new test. This is again new object. Now this is also new object. It's having reference of test T, new test T. Whenever we call test clone method, it will go and execute create the new object. Here also it will create a new test object. Now, whenever we change the original object, it won't reflect in the duplicate object because here we have new test object. Let's go on down. Should give 220. If we change the original, it should not reflect in the duplicate object. Now, if we go and change the original, t1 dot t dot a equal to 100. It should not reflect in the duplicate. This is a change we have to do in the clone method to make it a deep copy. This is for deep copy. This line of code. If somebody asking, write example for the deep copy and shallow copy. Return clone. Now, if we call this, it is a shallow copy. So, whenever we change the original object, this will change. This is a shallow copy. Same example, useful for the both. We are not using this shallow copy, deep copy anywhere mostly, but we have to know the concept. This is for the interview. Shallow copy, deep copy. And this is called cloning. Now today we have seen finalize method and clone method. How to use a finalize, how to use a clone. How to call the garbage collector by calling system.gc. Even though if we call the garbage collector, we are not telling forcibly to the garbage collector to go and execute and delete the abandoned objects. We are just requesting the garbage collector. Once in a while, it will go and execute and delete the abandoned objects. Now, what is the deep copy and shallow copy? Shallow copy. Whenever we change the original object, if changes are not reflecting, changes are reflecting in the duplicate. So that is called shallow copy. Whenever we change the original object, if changes are not reflecting in the duplicate object, by calling the clone method, we can create the duplicate. So that is called deep copy operation. This is two of the operations. In case of abandoned, okay. Today I think that's all we can see in the tomorrow class. We have seen the most of the things in the object class. This much is fine. But this program, if somebody asks, write a program for the deep copy or shallow copy, we should be able to write. Don't take this many attributes also. We can remove. Take any one single attribute. Int X. We change the X is changing here. Change the A is changing here. So it is shallow copy. We change the code here. This one, creating new object in the clone method. It will even if we change the first original object, it won't change here. This is an important program. We can see in the tomorrow class.
Paint as in the